Alright, hello everyone. Welcome to my channel. This is an educational channel where we look at theories of everything, all-encompassing theories, contributions from crackpots, their magnum opuses, and their lifetime accomplishments. And we try to put them into context and see how you and me can benefit from these things, and how we can make sense of them and put them into a paradigm shift. Today is our 356th video on Dewey B. Larson and his reciprocal system of theory. Mr. Larson lived in the 20th century and died in 1990. He left behind a bunch of books and articles and an organization structure and a few people that were willing to extend his work, revise slightly, and try to move it forward. The basic idea behind the reciprocal system is that we live in a universe that is made entirely of motion. Not made out of matter, it's not made out of energy or force. All three of those things are actually merely varieties of motion, as is every other scientific quantity that you can name. They are all forms of motion, and motion is characterized by Larson as the relationship between space and time. So all of these different scientific quantities are fractions with time or space as the numerator and space or time as the denominator. The relationship in both cases of time to space or space to time is motion. And when Larson refers to motion, he's generally referring to what he calls scalar motion. And a scalar motion is a motion that is distinguished from like a vectorial motion. That is a motion in a specific direction. A scalar motion is a motion that does not have a specific direction. The way you would visualize this is by taking a balloon and putting a bunch of dots on it. When you blow up the balloon, all of the dots are moving away from each other. The farther away they are, the faster they're moving away from each other. But they're not moving in any specific direction. And that is a scalar motion. That's a scalar motion in space. The space itself is expanding. All of the dots are moving away from each other, farther and farther and farther apart. But again, no specific direction until you assign a reference point. When you arbitrarily determine that one of the dots is motionless, then you can begin to start measuring the directions of those different motions. But that is an illusion that comes out of the assignment of a reference point. It's not an inherent quality of the motion itself. The motion itself has no direction. And this is also seen in the clock in terms of time. The clock is always getting later and later and later, but it's not moving in a specific direction. It's just getting later. And so Larson refers to this as clock time and clock space. So clock space is the movement of the dots in all directions. And just to point out that that applies not only to the dots, but it applies to the spaces between the dots. They are all moving away from each other as well. It's the fabric of space itself that's moving apart or expanding. But it also works in the other direction as well. If you suck in the balloon, all of the dots are moving toward each other. That is a scalar motion as well. Now, another prong of this is really coming from Larson's first postulate. He had two fundamental postulates that he put out in the late 1950s after many, many years of kind of ironing it out. And then he took his two fundamental postulates, and from them he derived a theoretical universe, how that universe would look if these two postulates were correct. So the first postulate is, the universe is made out of motion, which he originally called space-time, but then he began to call it motion instead. And motion is a relationship between space and time. And space and time have their coordinate aspects, their clock aspects and their coordinate aspects. Now, coordinate space and coordinate time is another aspect, and that basically means three-dimensionality. We understand clock coordinate space, XYZ coordinates, or volume. We understand 3 dimensions of space. But there are also 3 dimensions of time. Merely because time and space are reciprocals of each other. Just to refresh your memory, in case your math is rusty, the reciprocal of 3 is 1/3. 3 over 1 or 1 over 3. You're basically inverting a fraction. And when you multiply two reciprocals, they multiply out to be 1. And all reciprocals have the same qualities, but they have them kind of in a different order. In this case, 3 and 1. In the case of the first number, it's 3 over 1. And in the case of the second number, it's 1 over 3. So they have the same qualities, and so too with time and space. So if space has a certain quality, time also has that quality, even though we might not be able to see it so clearly. Like, for example, clock space and clock time, we're pretty comfortable with the concept of clock time always getting later and later and later. But clock space is a more unfamiliar concept, but it stems from there being clock time. And so too with coordinate space. We're comfortable with that concept of 3-dimensional space, but it also applies to time, coordinate time. Time also has 3 dimensions under certain circumstances. And then time and space also come in discrete units only. They are, there is a minimum unit of space and a minimum unit of time. And you have to have a full unit before you have anything. If you don't have that full unit of space or time, then you don't have space or time. And for space, that unit is approximately 4.56 times 10 to the minus 8 meters, or about 1/500,000th of an inch. And then for time, it is 1.52 times 10 to the minus 16 seconds. So you would end up having trillions of them, quadrillions of them in just 1 second. And these are discrete units, so it's not like there's continuity in this universe. There are discrete frames, but there are so many of them and they're coming by so quickly that you don't notice. In the same way that you won't notice that a motion picture is a bunch of still frames flashed before your eyes all in a rapid succession. It looks like it's continuous, but it isn't. And if you have exactly 1 unit of space in 1 unit of time, space over time being a fraction, so therefore it's a motion. And in the case of space over time is speed. The car is moving at 15 miles per hour, 15 miles of space in 1 hour of time. If you have 1 unit of space in 1 unit of time, you have the speed of light. And Larson refers to that as unit speed. 1 over 1 equals 1. And this unit speed in the universe of motion is the background, or the state of rest, or the ether, the origin, the reference point, or the Larson calls it the progression of the natural reference system. This is the background of the universe of motion, which makes sense. If you have a universe of motion, you have motion before you have anything else. Motion precedes everything. And then from that motion, you are either going faster or slower. That would be a displacement from up or down. And you basically have a number line or a scale. So 1 is at the center, as it is in all reciprocals. As I mentioned, all reciprocals, when you multiply them together, you get 1. So this is a multiplicative system, not an additive system. You know, with legacy science, you start from 0 and you go +1, -1, +2, -2, or whatever. In the reciprocal system, you start at 1. And if you go plus, you go to 2. But if you go minus, you go to 1/2. If you go +2, you go all the way to 3. If you go -2, you go all the way to 1/3, and so on and so forth. So they balance each other out by multiplying to 1. And if you go in the direction of, 1, 2, 3, 4, 5, that's the positive direction, then you're moving faster than the speed of light. If you're going in the negative direction, then you're moving slower than the speed of light. So Larson says that the speed of light is a boundary of the universe, and that half of the universe is moving faster than the speed of light, half is moving slower than the speed of light. He refers to these as the cosmic sector and the material sector, respectively. We reside in the material sector. This is where we have our coordinate space and our clock time. But if we crossed over that boundary and moved into the cosmic sector, we would have to invert the roles of space and time. So if we cross over to the cosmic sector past the speed of light, and we move to the faster than speed of light area sector, or the cosmic sector, we would experience coordinate time and clock space. 3-dimensional time with space always getting farther and farther and farther apart. So that's kind of how it works. He then had the second fundamental postulate, which is basically not as important as the first, but it just goes that the universe follows the rules of ordinary commutative mathematics. Its primary magnitudes are absolute and its geometry is Euclidean. Now, we went through a paper a couple weeks ago written by Dr. Bruce Peret that kind of took Larson to task on that second postulate. in particular and got rid of a few of the terms there. And he prefers to say the universe follows the rules of ordinary mathematics. Its magnitudes are absolute and its geometry is projective. So he gets rid of the commutativeness and he gets rid of the primariness of the magnitudes. And then he substitutes projective geometry for Euclidean geometry. So you might want to look at that paper if you're wanting to know about the postulates. Now today we're looking at another paper from Bruce Peret. He has them numbered RS2, 101, 102, 103, 104. We're at number 107 today. It's called Mass and Gravity. RS2 is the reciprocal system 2, the re-evaluation of the reciprocal system that Dr. Peret did along with Dr. KVK Nehru, who kind of teamed up on some revisions of the reciprocal system that maintain the spirit of the reciprocal system and the basic ideas, but revise some of Larson's deductions, and Larson admitted that he was fallible in those areas. And so this paper here is called Mass and Gravity. It starts with the background. As discussed in the last paper, RS2-106, which is called Dimensions and Displacements, which we did just before this, Larson refers to units of motion that comprise the two aspects of a scalar dimension: speed, which is s over t, from 0 to 1, and energy, which is t over s, which is from 1 to infinity. So greater or less than unit speed or unit energy, either way. Unit, that's 1 over 1. So he's really referring to the material sector and the cosmic sector. 3 dimensions with 2 aspects resulted in 6 units of motion, which he then splits in half to create the 3 speed ranges for the material and cosmic sectors. So in both the material and the cosmic sector, you have 3 speed ranges, which he calls low, low, intermediate, and ultra, designated as 1 minus x, low speed, 2 minus x, intermediate speed, and 3 minus x, ultra high speed. The range number defines the maximum unit of motion, 1, 2, or 3, and the minus x, some fraction thereof, so 2 minus 1/2, or 2 minus 1/3, 2 minus 1/4, and so on. Speed ranges are discussed in more detail in The Universe of Motion, which is Larson's book on astronomy, as an explanation of the inverse density gradient of white dwarf stars, which comes from the intermediate speed level, and the anti-gravity motion of quasars and pulsars, which comes from the ultra-high speed level, the 3rd level, with both motions taking place in equivalent space instead of the normal space of our reference system. Equivalent space is the time equivalent of space, or the space equivalent of time. We don't see time, we only see space. So if something is occurring in time, we see it in space, but we see the inverse of it in space, because space and time are inverses. And so if something occurs, so this is basically your white dwarf star. a white dwarf star is a star that is exploding at faster than the speed of light. So when it explodes faster than the speed of light into the intermediate speed range, it's exploding in time, not in space. And when something is exploding in time, we don't see time. We only see space. And so we see something exploding in time as something imploding in space, because that's the inverse. And when we see something imploding in space, it looks like a white dwarf star, very, very small and very, very dense. So, the speed ranges are discussed in universal. Okay, the reason being that only a single scalar dimension can be completely expressed in the reference system. Again, this is from his paper from the other day, that we require 3 dimensions of space to describe 1 dimension of motion, of scalar motion. So there are 3 dimensions of scalar motion. So we are not able to actually perceive all of the dimensions of scalar motion. We only really can perceive 1 at a time. Here he says, the reason being that only a single scalar dimension can be completely expressed in the reference system, with the other 2 dimensions modifying the expression of that coordinate information via equivalent space. So when a star is exploding into time, we see the star in space, and we see it's modifying motion, which is the implosion, in equivalent space. So when we go beyond the speed of light, then we start seeing in both space and equivalent space. But we don't see the whole motion. We're just seeing it as a modification of an already existing motion. This is at variance with the equivalent space concept used at the particle and chemical levels, discussed in Larson's book Nothing But Motion, which is generally on atomic physics, where equivalent space is treated as the spatial expression of temporal motion. Granted, this does work for the second unit of motion, the energy, but does not work for the third speed in a second dimension, because the third part of motion is already space, and therefore cannot be in equivalent space at the same time. Now, just to make it very clear to you, this is all quite confusing to me as well. So I'm just trying to ride it out and go along with it. There's a few things here that I'm very puzzled by. But that's kind of how you have to work with the reciprocal system. You have to accept the fact that you're going to be puzzled, and that it probably will work itself out eventually. But in the short term, it might be a struggle. In Gustave Le Bon's book, The Evolution of Forces, which came out in 1908, he discusses the difference between mass and weight as they were interpreted by the 19th century researchers. Conventional science treats mass as force divided by acceleration, typically the acceleration of gravity. The older approach is to treat mass as weight divided by velocity. So mass as force over acceleration, that is t over s to the second power, and that is divided by s over t to the second power, which is acceleration. That totals out to be t to the third power over s to the third power. But in the more older approach, or with the more modern approach, you have with the older approach, you have weight over velocity. And here he's saying that weight is t to the second power over s to the second power, and that is divided by space over time. And that is also t to the third power over s to the third power, which is mass. So that may or may not be of any importance at this point. The older definition is actually closer to the reciprocal system atomic model because particles and atoms are defined by magnetic and electric rotations, an angular velocity. In Larson's ABC displacement notation, the A and the B magnetic double rotations have the dimensions of t over s times t over the s, t over s equals t over t to the second power over s to the second power. The same units Laban refers to as weight. The electric rotation is an inverse spatial angular velocity, s over t, matching the velocity component. The older definition of mass precisely matches the A-B-C displacement structure of particles and atoms used by Larson. Mass equals magnetic rotation over electric rotation. T over s, the quantity squared over s over t. In the reciprocal system, the concept of mass is mathematically determined by the net temporal displacement of the atom, its angular velocity in time. The magnetic rotation therefore accounts for the primary mass of any particle or atom, which is then slightly modified by the electric rotation in equivalent time, the time equivalent of space, being the reciprocal concept of equivalent space. Now, I don't quite get that either, because I'm under the impression that we're using equivalent space because we don't see time, we only see space. And so if something is occurring in time, we perceive it. It really is occurring in time, but we perceive it in space as the equivalent of that by the inverse postulate. But I don't see why we would need a concept of equivalent time, because we don't see time. So anyway, but maybe it is that we do see time in the material sector within the time region, which is the region of less than 1 unit of space. Anyway, that is where we're going to sum it up right here. The next section of this article is called Gravity of the Situation. And so we will go into, his discussion of gravity, being not entirely satisfied with his discussion of mass, I have to say. But, again, that is kind of the nature of working with the reciprocal system, is that you need to be able to suspend disbelief and just let the information wash over you and decide at a later point whether to accept it or reject it, but not before you've seen the whole picture. And, that's where I am with Larson still. Is I really believe in his concepts and how it works, the system itself, the simplicity of it, but applying it is a different matter, and sometimes the applications are rather strained, and so it's hard to figure out the full picture. That's why we need like thousands of people working on this. Okay, hopefully you're not too confused, and that you come back tomorrow to listen to the rest of this article. And thanks for tuning in today. Have a great day.